So one reason I don't believe in Conway's law is because I break it so often. When you break something like that, it must not be a law. There is a school of thought, especially in the microservice community, about something we're calling reverse Conway's law. And the idea is basically we're saying the architecture of your system will drive how you need to organize yourselves. If your architecture is sort of a centralized architecture, big components, shared fields, you're going to have an organization that has dedicated departments to these things. You will have long integration cycles. If on the other hand, you have a very loosely coupled system, you may have very small, very fast teams. That tends to be the environment I tend to set up. So this is a talk I've been doing, this is probably put together about a year ago for basically a conference in Perth, Australia. And it sort of was because I have a varied background. This chart has all the data. It basically says I'm really old. This is more or less what I really do. I am a change agent. Going back to Jamie's talk this morning, I am the guy who goes in there and breaks the culture and rebuilds it. I'm very good at doing that. In fact, my job description at the Daily Mail was a hand grenade being thrown into development. If you can ever get this job title, you should take it because it's quite a bit of fun. So this is kind of what I do is, and to some degree, because I've kind of lived on the edge of technology my entire career, a lot of things you're going to hear about today are going to be very strange. They may not be appropriate for you yet. That's okay. But my best guess is within the next 3 to 5 years, you'll be doing a lot of things I'm talking about. But basically, it's kind of all bleeding edge things. So I go to a lot of conferences, I speak to a lot, it's kind of my way of touring the world, and I see a lot of topics. Certainly microservices is a very hot topic now. There's dedicated conferences to it. The one in Berlin is quite excellent. There's also almost all conferences have at least a track or several presentations like we do this today about microservices. But I'm hearing a lot of other topics. You just heard one about Docker. In fact, their entire conferences is dedicated to Docker and some of these other topics. But you're also seeing, Agile and there's a lot of new Agile stuff coming out. There's kind of a next generation of Agile, so a very aggressive Agile. I have a version I call Programmer Anarchy, but recently Eric Meyer, for the last year or so, has been talking about one hacker away, which is, again, a very much advanced Agile process. It's worth your time. So that's all going on. And then, of course, the business guys can't be left behind. They have their own version of Agile. It's called Lean Startup or Minimum Viable Product, and they're getting a lot of press, have their own conferences about these sorts of things as well. And also, all of a sudden, now we're having new titles becoming popular again. DevOps, which I find kind of entertaining because, as I say in a minute, I think it's the DevOps guys getting together having a conference. And it's interesting when you go to these conferences because it's basically just ops guys. There's no devs. And it's ops guys saying, oh, do I have a job? Yeah, I still have a job. Do you still have a job? Yes, we still have jobs. Not sure that's actually true. But the other thing is full stack developers. All of a sudden, something that we're trying to go away from since the 70s, we're coming back saying maybe it's a good idea to have these guys that can do everything. There's a common theme here. Every one of the people are doing this in order to go faster. They're trying to go faster from the time something is needed till I get it out the door. This is what's driving all these conferences and all these topics and all these technologies. So I want to talk about that. Now, why do we care about this? Well, one of my favorite ways to sort of describe what's going on to some degree and what's changed across my career is this model that comes from a guy named Dave Snowden. Being named Snowden means he does not get any more first-page hits. He used to get a lot of first-page hits. He doesn't do that anymore. But he's a Welsh guy. He actually divided the world into these sort of segments. He said problems can be classified. And he called a simple problem one where the cause and effect relationship is very straightforward. If I turn the light switch, the light comes on. I turn it back off, it goes off. He said there are also complicated problems. There's a cause and effect relationship there, but it's much more convoluted. It is the domain of the expert. He understands what the cause and effect relationship is. He is your expert. But he doesn't stop there. He says there are also problems that are complex and chaotic. A complex problem is one where the cause and effect relationship is not discernible. Yes, if this happens, you can probably figure out why it happened by backing up, but that doesn't help you the next time. It's not a predictor of the future. There's a large class of problems that this meets. This is, in fact, your financial markets. This is Google AdWords. This is the recommendation that decides whether I should loan you money or not, or what sort of book you should read next. These are fuzzy problems. Now, the problems we used to solve in the 70s and 80s were complicated. We started putting our payroll systems together, accounting systems, that sort of thing. But now we're moving into beginning to solve a suite of problems called complex. And these complex problems can make you a lot of money if you do them well. Now, the other thing Dave Snowden would say basically is that you start out in some sort of state of disorder, which means you don't really know what type of problem it is. And Dave, being a guy who studies this in industry, basically says 85% of the time, you do not know what type of problem you're working with. You need to watch how it acts. Does it respond to these experts and the advice? Can you predict the future, or is it unpredictable? Figure out what type of problem you're working on. It also turns out you have a prejudice. As an individual, you kind of have a prejudice about where you like problems to be. It's like your little happy world is one of these quadrants. If you're Donald Trump, it's simple. You elect me, I'll fix the problems. I'll raise the taxes, I'll put a wall up between me and Mexico, we'll do something that'll solve all my problems. Of course, the problem is really complex, and those sort of solutions are nonsense. I tend to be a guy who loves the complex environments. I sort of love the cowboy nature of this. There are no rules here. I kind of like those sort of environments. I've been known to take normal problems and turn them into complex problems just so I can have fun. You be careful when I come work with you. So this model kind of helps. We're solving complex problems. Those are the ones that are making money. And a lot of problems I've been solving over the last 10 years have been in the complex domain. And a lot of the techniques I'm talking about work extremely well there, but may not work so well in the other domains. All right, the other reason this becomes important to go really fast is you got competition. And competition has two key advantages now versus, say, 10 or 15 or even 20 years ago. One of the advantages they have is they no longer have to go get themselves a lot of startup money, go buy themselves $1 million of machines, go hire 100 programmers to work on these machines for a year to build the software to compete with you and your business. They can go actually straight to the cloud, get computing power. They can go straight out there, get frameworks that do amazing things that 20 years ago we wouldn't imagine, and they're free. You're not having to pay Oracle $1 million a year for something. And they got great new languages that allow them to express their algorithms even more efficiently. So the technology barriers for competitors are going away. But it's even worse than that, because the business side of it is also strange. Because now they have a way of which they can build a business up almost from the ground up, based on the Silicon Valley models. There's all these companies in Silicon Valley have been very public about how they start themselves up and how they get going. And so there's a way, in fact, I can do these things. But also, because of social networks, they don't need a sales force anymore. They can go through social networks, reach out to huge communities, and basically suck away your best customers, and you didn't even know what was happening. Not until all of a sudden you do a portfolio analysis and find out all your banking customers are horrible customers. They're always late in their payments. Where are all the good customers? Got siphoned off. And also, I could be sitting in Bangalore and put in place a system that can run in Europe. Just drop it on the Amazon cluster in Dublin, and now I'm a European company. And so even the international barriers are down. So the competition is coming at us very hard. Either you're doing these things that I'll be talking about, or there will be a competitor out there doing them who will come after you. So you have to watch out for that. So the question is basically, how fast can you go? How fast can you get from that requirement all the way to get something out the door? So let's talk about some of the things that are changing and sort of what's happened over time. You'll see a lot of charts like this in my presentation because being old, you like to reminisce, and you're a captive audience. So we'll go back to just 2000. Most of you remember 2000, I think. That's a log scale on the side. And so we talk about how long iterations were. And I was one of the early guys doing Agile back around 1999 and 1998. And there were a lot of different Agile methodologies back then. Extreme programming was kind of the fastest in terms of iterations, 2 to 3 week iterations. Scrum was sitting about 2 or 3 months. And that was very fast compared to what we were doing before. Now, it turns out I did a lot of extreme programming in 3 week sort of cycles. And it turns out with a 3 week iteration, it seemed like the first week we were kind of resting, and the second week we kind of worked, and the third week we panicked. And it turns out panicking all the time is really productive. So I cut my iterations down to basically 1 week. But we didn't stop there. Actually continue to work with some companies in London. We wound up actually turning our basically our stand-up into our iteration planning meeting. What are we going to do today? That's our entire horizon. And then it got really crazy, and I'll show you how crazy it got. So this is a trend going on. And I would say if you're still doing an iteration cycle of 2 or 3 weeks, and you did that last year and the year before, you're not agile anymore. You should be going faster and faster. You should be pushing that envelope. All right, how long does it take to get code out the door? Now I'm going to go really far back here. Let's see, I think I'll go back to 1980. Maybe some of you were even born in 1980. I was working in IBM at the time. And basically, we were planning projects that would last anywhere from 3 to 5 years. In fact, I worked on a project in this time frame where we had a 3-year project, 1,000 programmers I'm working on it for 3 years. Don't feel sorry for us. We made $1 billion with that software. And we shipped it on time 3 years later. I was still working at IBM, and I sort of got a little bit faster. I mean, this is a log chart, right? So any straight line down on this chart is really a hockey stick. This is a really good thing to go a straight line. We got a little faster. I got to the point in IBM I was shipping things every 8 months, or 6 to 8 months. We introduced object-oriented programming, got a little bit faster, maybe 6-month sort of cycles. I moved out away from IBM at that point, was working in the Agile space, but we're still doing 3-4 month delivery cycles, even with all the Agile stuff and extreme programming. Then an interesting thing happened. We started tweaking a few other things in our process, and the bottom fell out. A2 kind of refers to aggressive Agile or Agile or something like Advanced Agile, but the bottom dropped out about how fast we could get code out the door. So how fast do we get? Basically, this is GitHub stats from the team. We were pushing something new in production every 3.5 minutes. Every 3.5 minutes. You think you're going fast now? You can go faster. So what were the inhibitors? What's keeping you from going at speeds like this? What's stopping you from doing that? So there's 3 categories I'm going to be talking about today. Technology inhibitors, some process inhibitors, and we'll wrap up with some organizational inhibitors. And these are, as Jamie was specifying, these are cultural things. And there's some things that culturally you need to break down. And these are some of the things I've done in the past to break these things down. So first of all, you can't be afraid to use what the CEOs call Valley Tech. Basically, these are companies very much like the bank who says, oh yeah, I'm the Netflix. Basically, the CEOs are saying, what can I do to be like these very successful Silicon Valley companies? And the answer is, you look at the list, and it's going to be like, you're going to exploit the cloud. You can't be afraid of the cloud. You've got to use new languages. Open source. Don't be afraid of open source. And I can't tell you how many big clients I go to says, oh, we can't use open source. It's not reliable. Guess what? Your competitors aren't afraid of that. They're after you. And moving to continuous releases. So these are things a lot of big companies don't do, but if you're not, when they say I want to do Valley Tech, and you look at what the Valley's doing, this is the list. So you got to be ready to go do these things. Another good graph chart. How long does it take to get hardware? And what has that done to this problem? Again, I'll go back to 1990. Again, most of you hopefully were born by then. It used to be back then, it'd probably take about 6 months to get a new machine. You have to sort of figure out what you want, order it, it would come in there, you have to sort of put it in place, make sure it all works, and then it's available for usage. And that's kind of a lie. Because generally you had to make sure you allocated the capital equipment the previous year for this machine. Which means you went through some capital planning process. It may take a year and a half to get a new machine in place, which means you've got to be pretty sure what you're going to use it for because you have to justify that expenditure. Fortunately, virtual machines came along and we were able to carve this machine up into smaller pieces so we could sort of change our mind a bit. And this was a very powerful thing. And so you could probably get a virtual machine in a week or so. Then the really bottom fell out. Amazon comes along and says, oh, by the way, I'll sell you virtual machines. And you can sort of ask for them, I'll get them up pretty quickly. Maybe it takes 30 minutes to sort of get one, 5 or 10 minutes if you get really good at this stuff. And we thought we were very happy with it. We were amazed by that. Of course, we didn't hit Docker yet, which is in like the second range. Several seconds I can have a new one up. I have a company in Las Vegas where I live. They're doing sort of financial transactions with Docker. They bring your Docker machine up, run one transaction, and throw it away. Just throw the machine away. They don't worry about memory leaks. You don't have a memory leak for the next 5 seconds. That's it. And then throw it away. You're never going to run out of memory in 5 seconds. So I'm not going to worry about this problem anymore. So what's happened is that based upon this sort of thing, if you really watch what's going on, what you should be doing, all of a sudden in this world, capacity planning, the idea of sitting down at the beginning of the year, figuring out what you need machines for and how much you need, is a useless exercise. Because it's not a capital expense anymore. It's an operational expense. If you need it, you can make money with it, go get it. Nobody's stopping you doing that. But you have to tear down a lot of structures in large companies in order to do this. That's a change. The other thing is this concept of ops team, which were necessary to try to get some machine up and running and give me some virtual machines. Those are very important guys. In this world, they're not so important. This is why they call themselves DevOps and trying to convince themselves they still have jobs. They don't. Now, there's an impact to what's going on. So basically, the whole movement that we're talking about today has to do with that curve right there. So what's the impact of services? Again, log chart in this case. Just wrap your head around that. So I kind of plot on here how you develop software. Basically, this is a traditional way of doing software. I call it the Rails and Java zone. It's really, and the idea is it's one big application. It can be 100,000 lines of code, 1 million, 10 million lines of code. It's a monster. Well, we knew that was kind of a bad idea. So, back in the late 90s or early 2000s, service-oriented architectures came in place. Credit Suisse was one of the big guys in this space. And they took their big systems and started carving them up into 50 or 100,000 line of code systems. Along Conway's Law, by the way. And they built systems like that. But with that aggressive curve with the virtual machines and all the way down to Docker happening, you have this new zone on this chart. I would call it sort of the microservices zone. Click, yes. And it basically is sort of this part of the chart, where basically it's maybe a 10-to-1 ratio between lines of code and number of services. This is why I used to work on projects in this space. I will never do that again. My life is too short. These are not fun things to work in. I run a workshop Monday where we basically wrote some services that did some very interesting things. And we basically were going to write about 10 or 12 services. They were going to be about 50 lines of code each. The company I worked in London, the one that was going every 3.5 minutes, that's where they are. That's how they work. Over 300 services, none more than probably 100 lines of code. Constantly adding more and more services to that space. This is Adrian Cockcroft and his Netflix implementation. 1,000, 2,000 lines of Java code, 600 services. I think that was kind of the last number I heard. Could be more now. But this is where Adrian and his guys built. This is where you're building the new applications. This is the microservice zone. And it's because of that hardware curve that we can do this. The microservices has emerged in parallel. I had no idea Netflix was doing this when I was doing my work in London, nor did I understand what the Guild guys were doing with their application. Or 4 or 5 other guys I've seen come up and say, we've been working the last 4 or 5 years building microservices, have this amazing system. We all saw the same phenomena. We all reacted the same way. Okay, so the other thing that's happening is the event bus is becoming a technology that's sort of key to making this sort of thing happen. What do I mean by event bus? Traditional structure says I have an operational SQL database. It kind of has the entities all for an operational perspective. I also have another one I use for reporting because I know I need to organize that differently. The operational SQL database is dead. That's the thing that's going to slow you down because you touch that thing, all your code has to be retested. That's why you have specialists associated with it. You make special changes, migration scripts. All this is because I have this very, very fragile sort of system. So the Silicon Valley guys are moving to event buses. So instead of having an operational SQL database, they just take everything going on and put it on an event bus, a persistent bus. So how does that look? One of my favorites is Kafka. Kafka is the event bus that came down of LinkedIn. So LinkedIn uses this for all their systems. And they open source it. It's an Apache project. The documentation on the Apache side is excellent. There are also now many other buses coming available of the same nature. This is a very dumb bus. It's not one of these enterprise service buses back from 10 years ago. This is a very dumb bus. It just takes messages in and gives it to anybody who wants them, period. And it's persistent. But it's also very, very, very fast because it's dumb. It'll handle 250,000 messages a second. Now that's a lot of messages. You got to think about what's going on. So one of the things you like to use these buses for is put everything on them because they have the capacity for it. Now it turns out these guys, when they talk about the bus capacity, they're kind of cheating. It turns out if you write the message one time, you read it 10 times, that counts for 11 messages. You're like, whoa, really? So if I've got 100 guys on this bus, 250,000 now becomes 2,500. Not such a big number. So you try to minimize that. And minimize that basically by writing a little microservice that hangs off here, which pulls the traffic in, filters it to see what is interesting, and then gives it to people who care. So basically I attach these little things I call rivers to this big bus, and they pull off sort of theme messages in themselves. And it turns out in systems I've built so far, I don't need more than like 8 to 10 rivers total. So my capacity on a bus stays at least 25,000 or more. Very good for my systems. And so basically what I do is I attach my service to one of these little secondary services, these second tier services, but I always publish back to the core bus. So that's the architecture put together for using event buses in this world. This begins to replace my centralized database. Now that will lead to some different architectural patterns as well. So using this sort of architecture, you build different systems differently. And this is how we built a lot of our systems where we made this a lot of money. So, you're sitting on here, you're sitting on a bus, and the service says, I have a need for something. Should I loan you money? Ask the question. Now, there's all sorts of services that you could write to sort of just give advice about that. Not one big guy who's going to make all the calculations, but lots of little guys making different calculations. Look at your bank account history. How many you've got regular payroll deposits. What's your credit card balances look like? What's Experian tell you about you? All the different little services going to be voting on that. And they vote and tell you what the answers are. And then you collect the answers back and decide, okay, given that wealth of advice you've been given, should you loan this guy money or not? And it turns out this sort of structure is very powerful. The little blue service doesn't know about the green service. The fact that I have one that looks at Experian and another one that looks at your bank account, they don't care about each other. All they're doing is responding to a question, should I loan you money? It's easy to put in version 2 of the service. In fact, I can run version 2 in parallel to version 1. Not have to tell version 1 about it at all. And in fact, if some of the services go down, I'm still giving advice. Maybe not as good advice as I want to give you, but it's a complex problem. I'm guessing anyway. It's fuzzy. So this sort of architecture becomes very easy. It's easy to write variations, and it's a very robust architecture. If one of these services go down, I'm not down. I keep giving answers. A very powerful structure. And this allows you now to build what I call incremental applications. By incremental application, I mean now you can sort of write an application that has a few of these services like that. So I'm giving in this case, advice on what sort of advertisements I want to show. And that's up and running. And I can start making money. And the ROI calculation on these projects is very, very high because I spend a little money, get something back. But then I can keep adding more services. I can add more, give more information about the customer, their membership, what are their usage patterns and buying patterns, and give that advice, and then make it a little smarter, and keep making it smarter and smarter day after day. So I can now build incremental applications using these sort of architectures. That, again, makes me fast. The other thing that's going on, as I said, is that we've got to go kill that big database. Recently, a few years ago, I was at a hotel chain. I was talking to their chief architect. And since I'm basically a troublemaker, I went to him and sort of said, how many operational databases do you have? And he says, we have 3, and we're trying to get it down to 2. I said, that's really kind of interesting because the right answer is 300. It was the last conversation we ever had, which was kind of okay because he was going to go tell his vendor about his new waterfall method next. He was like, dude, I don't want to talk to you either. So the new vision is basically you're going to use that event bus. It's sort of your new backbone system structure. Then it just takes everything interesting going on, it's in that bus. And then you're going to put a database in each of the microservices that needs it. If you need persistence, have your own little copy of the information. So in some conferences we talk about the idea that we rather cache the information locally than try to go query it remotely. We're preferring to cache the information. And particularly for that segment called complex problems, this is a very powerful strategy. The nice thing is, by the way, since I can, I have no idea what happened. I don't know how to do that with my tool, so whatever that last bullet is. So it turns out just because you need transactions as a service doesn't mean all the rest of us are stuck with Oracle. We can use key value stores as something else that's very sane. I mean, you still need a transaction system for transactions, but the rest of us are not stuck with that database choice. And that makes us faster. Oh, Microsoft wants to update my software. Thank you very much. Not now. Yes, thank you, Microsoft. And so example, going back here, when I'm writing this little service that's asking for things, actually I wind up writing 4 little containers to do that service. So my one service, so I'll have a little service that sits there and publishes something on the bus saying, I need an advertisement on my page. I have another little service I'll write, another little container that basically sits there and sort of gets all the answers back and pops them in a Redis database, which is running its own container. And then I got yet another piece of code that's sitting there waiting, say, 300 milliseconds and saying, oh, after 300 milliseconds, I better pick the best answer and send it back to the page. So 4 different little containers running, 4 little things. I would still call that one microservice because it's sitting around one database. If I change the Redis database structure, all 3 pieces of code may have to be touched. Similarly, if you look down this little piece at the bottom called membership, basically what I'm doing is I'm looking up to see if this user is a member of our frequent renter program. Is she silver? Is she gold? Is she platinum? So it basically has a little piece of code sitting there. It's pulling it off a key value store because that's all I need. User ID mapped to status. And that user ID and status is probably updated every night from the data warehouse. So I write myself a little ETL microservice. It runs as a cron job, wakes up, runs a query, refreshes my database. And by the way, if that doesn't run tonight, okay, maybe I'm using day-old data. That's okay. It's a complex problem. I'm just guessing anyway. Fuzzy problems allow you to do those freedoms. So that's the concept of having your database sort of just scattered throughout your services as part of your technology. The other thing is the open source. You can't be afraid of the open source stuff. Adrian and his team built Netflix, and they open sourced an incredible amount of their code. It is, in fact, the system by which many companies are building their big new systems or off the Netflix stack. If you told me I had to go build one of these 2 million line of code systems, that's the system I'd build it on. Very robust set of architectures. Now, 40 open source projects in there. Basically, they're too complicated. As Adrian has been before, it's more than you can possibly get your head around as a programmer. So there's a lot of great stuff in there, but you better think about it hard. But that is a system by which you could build some really robust systems. And of course, there's Docker out there, all open sourced, heavily endorsed now by all the major vendors. You should be on that technology as well. So don't be afraid of the open source. It's an avenue. And finally, there's some disruptive technologies coming along the point of languages. Some of the functional languages are very interesting. And you sort of look at some pieces of code we like to use, things like Kafka. Kafka is actually written in Scala, not Java or C++ as a high-performance bus. It's written in Scala. And RabbitMQ, one of my favorite pieces of software, extremely reliable, was rewritten a few years ago to become more reliable and written in Erlang. Erlang? They're using languages like that. And basically, I've done the same sort of thing in companies I've worked with. At the Mail Online, we were trying to rebuild and build the pages on the Daily Mail. And it turns out it took 130,000 lines of Java code and JSPs to actually render the pages of the Daily Mail. They're massive pages. There are lots of different pages. We couldn't change that system anymore. It's getting too ugly. So we rewrote that in Clojure. 4,000 lines of Clojure replaced 130,000 lines of Java. Way more flexible now. So if you're not using things like these disruptive languages, you don't have knowledge of what these languages are, you're at a competitive disadvantage. You need to understand how these things work. All right, so there are also process inhibitors. So as much as the technology, we kind of get our heads around that, yeah, cool technology, but you need to fix your processes as well. First process thing you got to do is you got to understand what type of problem you're solving. If you're organized to complicated problems, you have architects and key designers. You have development teams that implement what the architects tell them to do. That's the traditional organization of an Indian software company. It works really well for complicated problems. It does not work at all for complex. Because in a complex problem, those experts are useless because there are no experts. We sometimes tell the story about what's the difference between the expert architect and a used car salesman. And the answer is a used car salesman knows he's lying. So yeah, if they say they don't know how to do it and it's a complex problem, they're lying. So it turns out you organize yourself differently for this sort of problem. So figure out what type of problem you're working on. You may be working in a very traditional sort of application. I'm not sure microservices are going to provide you much advantage. But if you're working in these complex environments, you want to be there. The other thing is we got to change our mind about what we're trying to build. Wow, the clicker loves clicking. Back. So generally, we traditionally have put our requirements in stone tablets. To some degree, this is my fault. Not personally necessarily my fault, but my generation's fault. Because at some point in time, back in the 70s when I was writing code, I'd sit down with the customer, write their application, because it's small. But as it got bigger and bigger, it was like, tell me what you want and leave us alone. We got to put a team together to figure this out. And we kept pushing them further and further away. So put your requirements into stone tablets, sign them in blood, we'll implement them. It turns out that's not what you want to do for a complex problem, because they can't tell you how to solve a complex problem. They don't know either. So you want to move basically to a paradigm that says, how fast can we try out new ideas? So don't tell me about your requirements. I don't want to hear about requirements. I don't want to hear about detailed stories. Tell me what you're trying to accomplish. Give me some ideas about how you may make money or get more clicks or have longer page retention time. What are your ideas? I want to try these ideas as fast as possible. As one of our companies in London, we use this expression, experimentation drives innovation. I love the word experimentation, and it implies we will try things and they will fail. Get over it. We also need to rethink our interaction with customers, particularly for the complex problems. So most of your traditional agile processes all have the concept of stories, and stories can be broken down to tasks. But a colleague of mine in ThoughtWorks about 10 years ago, we sort of built this pyramid that says, but stories are part of something bigger. Sometimes called mega stories. I call them features. But features are part of projects, and projects are sort of part of business initiatives. And almost all of the agile processes, and probably the ones you use, say this is your level of interaction with the customer. He defines the stories. We count stories, we measure stories, we track how stories are done, how many we get done, how big they are. Everything's about a story. When I actually go into organizations doing agile or think they're doing agile, you listen to their stand-up meetings, and it's all about at the task level. What task did you work on yesterday? How long did it take? Why did it take more than an hour? You said it was going to take an hour yesterday. Why did it take more than an hour? And as a programmer in this world, you're like, oh God, please, what time is it? Can I go home yet? Because this is no fun. What we've done in the organizations I've been working with, again, cultural change, is we want to interact with the customer at this level. We want the customer to come tell us, what are you trying to accomplish? What are your goals here? Describe to me your business success metrics. If you don't know what those are, you're not ready to have a conversation with me. What are your KPIs? Your key performance indicators. So basically, the customer's job is to come teach me your domain. And some guys say, well, my domain is really complicated. You can't possibly understand what I do. I'm saying, dude, you ever try to deploy to Amazon? You ever try to use Clojure? Or JavaScript? You think your world's worse than mine? Change jobs any day. I can't understand what you're working on. I am that smart. So yeah, teach me your domain. A new paradigm, a different way to work with our customers. And try to reverse that trend of go back to the 1970s where the customers are sitting with you describing their problem. And you're figuring out how to write code for it. The other thing we want to do is you want to measure what really counts. I've been measured on many, many things in my career. I mean, I've been doing this a long time. You name it, I probably were measured against it. I mean, I used to count how many lines of code I wrote, how many classes I wrote, length of path, function points were a key thing back in the day. To some degree, all these metrics were games. I play games with all these things. You give me a metric, I can win the game. So when we started giving this metrics, though, we changed our metrics when we started working hard. We said, okay, what are your business metrics? Is it sales? Is it page retention time? Is it clicks? Is it money? What is it we're trying to do? It's a business. Okay, let's measure that. Measure our programmers against that. Turns out we like to game these metrics too. So, we're going to game this metric and make more money today. The customer says, you made more money yesterday. What'd you do? Well, we tried this and made. You tried what? And it made money? Yeah. Okay, do it again. So it turns out, we're smart. We build algorithms. That's what we're good at. Give us a problem and we'll figure out clever ways to solve it. That's why we're programmers. We're algorithms. We like to do algorithms. Don't tell me how to do my job. So we want to raise up to the feature level and measure the right things. All right, last section. Okay, we got to change the organization as well. This is where the cultural stuff becomes very important. So what I've found is the key inhibitor to all this stuff is what I call over-specialization. That we're kind of over-specialized in our roles. And this is the result of years and years of sort of moving in that direction. And it's manifests itself mostly by the titles we give our people. So it sort of comes up, the theory is, of course, if you're a specialist, you're better at this stuff, so we should give you work that you're good at. But we completely underestimated the overhead of communication and all the work imbalances that happen. We haven't got enough front-end developers right now. Oh my God, what are we going to do? I guess we have to slow everybody else down. So I guess it turns out that we've institutionalized those specializations by the titles we give our people. Front-end developer, Java, back-end developer, all these titles. So a real case study, this comes out of the Daily Mail. The Daily Mail is one of these cases where we made cultural changes, massive cultural changes. So I had 50 IT professionals in the group I was working with, the guys that do the online system. I found over 25 titles across that organization, between the database, front-end designers, testers, ops guys. There were 0 people who understood what we were trying to do. The poor Scrum Master was sitting there trying to understand the big picture so she could make sure all the pieces were coordinated, and she wasn't capable of understanding that. So that's the problem we were running into. And it was rooted in the fact we had these titles. So we decided we would fix the titles. So we first of all defined what we thought were competencies we cared about. So we defined, I like this pyramid of master, journeyman, apprentice. Sometimes it has different names, sometimes at 4 or 5 levels. Doesn't really matter. But pick a competency model of some nature. And then we picked up the technology we thought were strategic for our business. Ruby and Java, iOS, Android, as well as web-based platforms, databases, both SQL and non-databases and the like. But basically, these were the key skills we wanted our team to have. And we assessed our people for each one of these things on this pyramid. So we got an idea. And we based our job titles upon the pyramid. So gone was the concept of project manager. Gone was the concept of team lead. Those were all gone. We replaced them with, we called you a developer if you were competent in one of our key technologies. We called you a graduate developer if you weren't competent in any of our technologies. Now, I'm not sure why I hired you, but the CTO liked the title, so I said, fine, we'll put it on the chart. We called you a senior developer, you're an expert. And this is our traditional path, right? You want to build yourself up from a novice all the way to being competent into becoming a master of your thing, whether it's databases or Java or CSS. But then we did the strange thing. We said we're also going to create a new title called system developer. We'll pay you the same as we pay these experts. And we pay the experts very well. We'll pay you the same, but you're going to be competent in 5 to 7 technologies across the space. You might read this as full stack developer. And we value these guys because these are the guys that can give a problem to at the feature level and they can solve it. The whole thing. Because they can say, this part looks like front end, this is back end, this is the sort of architecture I need. This is the platforms I need to deploy it on. Now they know they're competent, but they also know their limits. And so if they need the expert, they'll go grab experts when they need them. But they're capable of solving the problem. And these are the guys we wanted in the organization. And we told them that basically, well, there's one more tier here. We called master. So if you actually be a wizard in 3 to 5 things, we would pay you even more. We put it there for aspiration purposes. We didn't have any. Nor would I expect necessarily to ever have any. And we said, you got a choice as a career path with this company. You can go either way. You pick. And by the way, if you want to become a system developer, I will take you and drop you into a team where you're basically an apprentice in order for you to pick up the skills to add to your list. So over time, you can sort of get yourself all the check marks and become a more higher paid person without having become that expert. So I took this to human resources. So this is basically was taken to human resources, which was the Daily Mail is part of a 125-year-old company. It's run by Lord Rothermere, the 4th Lord Rothermere of his title. So I'm walking into human resources of that company, English company like this, with a Lord at the head, and saying, oh, I have a new way of classifying my programmers. What do you think human resources told me? They loved it. I'm like, you love it? Oh yeah, we don't want to classify these silly programmers. Oh my God, it's a nightmare. I have this page of descriptions. I try to match these guys up there. They're complaining all the time they haven't been promoted. You guys are going to take the responsibility for that? Please take that problem. So they loved it, and we implemented it. We got rid of the concept of project managers. We got rid of the concept of team leads. We went to basically pure developers. We also fixed the furniture. Everybody was sitting at desks, had their little cubes. We tore out the cubes. We made tables. This is actually, if we're doing this in India. We made tables and said, you'll sit at the table with your project. And if you're a front-end guy or back-end guy, but you're working on this feature, you're sitting at the table with everybody else working on this feature. And you make them mobile. So again, breaking down part of the culture, rebuilding it in a different way. We also didn't believe in dedicated leadership. We felt the leadership will morph over time as a sort of feature gets put in place. Originally, as part of a feature, you will have the idea that as the architect, I probably have a good idea how to split this stuff apart. But you get down to implementing, getting out the door, and shipping it, your architect's usually not your best guy for figuring out all those details. I mean, set up your Docker clusters and swarms and the like, probably not your architect doing that. I sort of got this from this book, Guns, Germs, and Steels. It talked about basically the idea that you don't need a dedicated leadership until your village gets to be at least 100 people. And I'm looking at, I have a dedicated manager for a team of 4 or 5 programmers. I'm like, seriously? I mean, what's changed in a human nature that I need a dedicated leader at this point? And we killed the concept. Yes, we do have leaders, but they're sort of do their other job as well. In a village of 50 people, the leader's out there working in the fields. If you need the leader, you can talk to him. But otherwise, he works in the fields with everybody else. We like that attitude. And the other thing we got away from is bringing work to the team. There's a tendency to reform projects and put programmers together, and that becomes your new team. But it turns out it takes a little while, my experience somewhere between 4 to 7 weeks, for the team to sort of gel, where we've sort of had arguments, we figure out what editors we're going to use, what architecture we use, what tools and frameworks. It takes about 6 or 7, and then we're not productive in that time. Then we're productive. So why are you doing this? Why you keep reforming these teams? We want to take the attitude, we're going to bring the work to the team. We're not going to play musical chairs with the teams anymore. We're going to bring the work to the team. So if you're a business guy, you got some money, then come sit with our team, we'll implement your problem until you run out of money. And then bring the next business guy in. We're not going to keep reforming the team. We know how to produce ourselves. So we flipped that model on its head. So those are the sort of things you need to worry about. If you're just doing microservices by itself, and that's going to be the thing you're going to try now, you will fail. You need to pick up a couple of other things on this chart to do in parallel to enable microservices to be successful. You certainly want to be in the cloud. You certainly want to think about container structures. You want to think about some sort of managerless process, especially if you're solving complex problems. You definitely want to get rid of your big databases. But this will allow you to go faster. If you pull this off, then you get the effects I saw in this chart. I mean, this is a hockey stick, right? This is a linear, on a log chart, straight line is a hockey stick like this. This is a hockey stick on the hockey stick. It goes crazy. You will go absolutely crazy with how fast you can work. And this will make you lots of money. All right, I'm definitely out of time. In fact, I'm way over time, but I'll cut into your coffee break. So I would say thank you very much. We aren't going to take questions, are we?
Well, we actually do have time for questions, and there are a lot of them. So no coffee for anyone. Thank you, Fred.
Yes. Oh, thank you. Thank you.
So yesterday we had Randy Sook talk about that you shouldn't probably start your new projects as microservices. That it's they once they become successful, you can probably go that way, but it might not. It might take too much time, and you might want to start with an all-in-one application. Do you agree with that?
No.
Okay. Good. Next question.
Well, basically, I would say that anytime I start out sort of with the idea of going to build me some sort of monolith to start out with, you basically are building yourself a legacy system from day one. This is just, you're wasting your time. You need to think about it harder and attack it differently. And I would say it's especially true if you're trying to solve a complex problem. If I was solving a complicated problem, if I got to do bank statements, I'm not so sure there's competitive advantage to using microservices yet. Maybe the traditional approaches are fine. But if you have an aspect of your problem around sort of fuzzy problems or complex problems, don't start down the road of big systems. You will be a failure.
So you talked about rivers and that you had this event bus where you had 0MQ connected to it. Can you elaborate a bit on that? Why do you have these rivers compared to the individual services simply fetching their messages from the main queue?
Well, again, basically the idea of the high-speed event bus is you want to put every possible thing on that bus you can. Because you want to put basically everything interesting going on. Not just the messages between your services, but you're also putting every log message on that bus. And your user journeys. And all your traffic stats from your server boxes are putting on that bus. You want everything on a common event bus that's going on in your world. Because you don't want to try to filter out who that is. And this is a lesson we learned from Google. But the problem with these event buses like this is that, again, if you put 100 guys on this bus, the capacity gets dropped tremendously. And I can't afford to put everything on it. I want to put everything on it. So the idea of these second-tier services to pull things off by themes is to basically minimize the attachments to that core bus. And by that process, I can make sure that core bus allows me to put still everything on that bus.
Okay, good. So say that you have a huge project with hundreds, if not millions of lines of code. Do you really believe that having this huge set of functionality, that it will be easier to understand if you split it into, small chunks of 100 lines of code? That means that you're going to have thousands of services.
Yes, it's definitely easier to understand thousands of services than millions of lines of code.
Yeah, because you will not have to understand every one of them.
Exactly.
Right.
And it's the same way that you develop a system using object-oriented programming. You build classes, but you don't look at individual lines of code in the class. It's a class. It has a job. And in a Java world, you put these into packages, and even the package has sort of a job and functionality. So you want to continue to have layers of hierarchy associated with that. But if I had a legacy system like that, and I would begin to put microservices into it by looking at the next feature that comes along and says, is this feature truly embedded into this thing, or is there a way to sort of tease it out, sort of tease out some information from your database, run this all microservices, and then maybe push the answer back into the legacy system? And for clients I've worked with over the last 10 or 15 years, that's kind of been the strategy we've taken to sort of re-implement things in a different fashion when you have a big legacy tarball.
That's all the questions we have time for.
Good.
Thank you.
Well, thank you. I'll be around today, so find me.
Yeah.
Thank you.
Go and talk to the speakers, please.